Right now, you are floating in deep space, in front of an object the size of a city, but it is no ordinary object. It is the densest thing in the universe, short of a black hole itself, the collapsed corpse of a dead star. It is barely 20 kilometers across, yet it holds more mass than our entire sun. And you are about to fall onto its surface, so let's live it together, all the way down. This is a neutron star, and to understand it, you first have to know how it was born. It began as a giant star, far bigger than the sun, that ran out of fuel and died in a colossal explosion, a supernova. In that final instant, the star's core collapsed, crushed inward by its own gravity, faster than you can blink. An entire dying sun, squeezed down into a sphere you could drive across in 20 minutes. The result is a density that breaks the mind. Here, matter is packed tighter than inside an atom. A single teaspoon of this star would weigh as much as a mountain, around 1 billion tons. The protons and electrons of normal matter have been crushed together into a solid sea of neutrons. It is, quite literally, one enormous atomic nucleus, the size of a city, spinning in the dark. Now you feel the first danger. Long before you arrive, its magnetic field. A neutron star carries the most powerful magnetic field in the known universe, trillions of times stronger than Earth's. If it is a magnetar, the strongest kind, that field alone would kill you from 1,000 kilometers away. It would tear apart the atoms in your body, scrambling the very chemistry that keeps you alive. And it spins unbelievably fast. Some neutron stars turn hundreds of times every single second, faster than a kitchen blender. As they spin, they fire 2 beams of radiation out into space, sweeping the sky like a lighthouse. If one of those beams points at Earth, we see it flash, again and again, with perfect, clockwork timing, a pulsar. As you fall closer, the star's gravity begins to bend the light around it. You start to see parts of its surface that should be hidden, curving up and over the edge, into view. The whole star seems to swell and warp, as if you were looking at it through a great, invisible lens. Its surface glows with heat, a searing point of blue-white light in the dark. And then the real danger takes hold, the tides. The gravity at your feet is now far stronger than at your head, because they are closer to the star. The difference is so violent that it begins to stretch you, pulling you out, long and thin. On a star this small and dense, this happens long before you ever touch the surface. The gravity here is almost beyond belief, billions of times stronger than the pull of the Earth. It accelerates you to a staggering fraction of the speed of light, faster and faster as you fall. Near the surface, time itself begins to slow, stretched thin by the crushing gravity. To a distant observer, your final plunge would appear to drag on, slowed almost to a crawl. Now the surface rushes up to meet you, and it is unlike anything else in existence. It is a solid crust of iron, smoothed by gravity so extreme that its tallest mountains are mere millimeters high. Beneath that crust lies a strange, super-dense ocean of neutrons, and deeper still, matter we have no name for. The whole surface glows at around 1 million degrees, far hotter than the surface of the sun. And then, you arrive, falling at a fraction of the speed of light. You strike the iron crust. The impact releases as much energy, in a single instant, as the sun pours out in years. There is no landing. You are vaporized, flattened, and absorbed into the star, in less time than it takes to think. From the outside, the star barely notices. It spins on, exactly as before, ticking like a cosmic clock. Neutron stars are the lighthouses of the universe, the most extreme objects we can still see and study. They are matter pushed to its absolute limit, one single step away from collapsing into a black hole. Each one is a dead star that refuses to fade quietly, beating in the dark, long after its light went out. A city-sized ghost, heavier than the sun, spinning at the very edge of what reality itself will allow.